The topic what we are going to discuss now is increasing and decreasing function. Alright, so this is the second, you can say, application of the derivative. Okay, so increasing and decreasing functions. Now, first and foremost, you need to understand what are increasing and decreasing, because there are certain ways of telling that what is increasing, what is decreasing and everything. Alright, now let's assume that you have a function, a very simple function. Let's say you have a quadratic function. Fine. Say, let's talk about an example of f of x is equal to x square. See, when you have f of x is equal to x square, let's draw the graph of this, at least, like an approximated version of the graph. See, the graph is going to go something like this, correct? This is x square. Now, for every value of x, we'll calculate what is the value of f of x. So, first you have x value, and now you have f of x value. Suppose if x is 0, then y is 0. That's very simple. Suppose say f of x is, let's say x value, let's say 2. Alright, say x value is 2, f of x becomes 4. Suppose if this is minus 2, this is 4. Right? Say you take minus 1 and you say 1. Now, whatever we have, we are going to get a value of f of x, right? Which is basically x square. Now, what we'll do, we'll take a value. So, let's say we take a value of minus 2. That means, say we are taking an example of x is equal to minus 2. So, your f of x value is 4, correct? Now, take x is equal to 0. Now, f of x value is what? 0. Now, what we are looking at here is you have, say, x1. This is x1, say this is x2. Like, in the sense, this is x1, this is x2. Now, in this example, what we are looking at is that x1 is less than x2, correct? Minus 2 is less than 0. And f of x1 is greater than f of x2, isn't it? Because 4 and 0. Now, what we do? We take another example, that is x is 0, x is equal to 2 with the same function. Now, f of x is 0, f of x is equal to 4. Now, what we'll consider? We'll consider this to be x1, this to be x2. That means this is x1, this is x2. Now, what we have? x1 is less than x2, correct? 0 is less than 2. But f of x1 is less than f of x2. Now, if you look at the previous example here and here, but for the same function, we are getting contradicting results. Because in one case, we are getting f of x1 greater than f of x2. In the same function f of x, we are getting f of x1 less than f of x2. In the sense, how do we declare what is an increasing function? How do we declare what is a decreasing function? And are there any functions which are neither increasing nor decreasing? That's what you're going to learn in this particular video. That is, what exactly is an increasing function? What exactly is a decreasing function? Understood? So let's talk about different types of functions. I mean, when I say types of functions, don't go into the first chapter where we talk about bijective, that, this and all. We are not talking about that. Okay, so here we are specifically talking about, is the function increasing? Is it decreasing? If it is increasing, how do you tell it whether it's increasing or not? All these things we are going to discuss in this particular video. All right, now let's discuss about what are the types. When I say types, talking about increasing, decreasing type of functions. All right, let's discuss about those types now. When we talk about these increasing, decreasing function, all right, so the first type, you can say increasing function. Okay, just increasing. Now, in this case, suppose say you have two values, x1 and x2. Okay, so assume that you have x1 and x2, and they are there in such a way that x1 is less than x2. Clear? x1 is less than x2. If f of x1 is less than or equal to f of x2, let me repeat, f of x1 is less than or equal to f of x2, then we say that the function f of x is increasing. Understood? Let me tell this again because it's very, very important. Suppose if you have x1 less than x2 and f of x1 is less than or equal to f of x2, then we say it's increasing. So what do we write and how do we go about it? A graph. Maybe you can say something like this one. See, like this. See, something like this. Still increasing. But f of x1 is equal to f of x2 at one particular point. But overall, the function is still increasing if you're going to look into it. Correct? So these are what we call as increasing functions. Next in increasing itself, we have one more type, what we call as strictly increasing. Okay, let's look into what is a strictly increasing function. Right? In this strictly increasing function, when you have strictly increasing, you have x1 less than x2, some value of x1 and x2, and f of x1 is strictly less than f of x2. There is no slack inequality, there is a strict inequality. That means now, say this is your graph. Let's say your graph is going to go something like this. There is no equal value anywhere. Anywhere in the graph, you are not going to have f of x1 is equal to f of x2. Fine. This is what we call as a strictly increasing function. Understood? Now we'll go into the next one, that is decreasing function. See now, decreasing function. See, decreasing function in the sense you have x1 less than x2. Okay, so you have a smaller value. Whereas f of x1 is greater than or equal to f of x2. Like in our example itself, that parabola we took it, no? So minus 2 and 0. Minus 2 was less than 0. Whereas f of x1 is greater than, sometimes equal to also. Sometimes greater than or equal to f of x2. So this basically is what we call as decreasing function. So here you can think of an example like this. See, something like this. So here, this is the value of x1 and you can say this is the value of x2. x1 is greater than x2. Or if you are going to take some value x3 here, now x1 is equal to x3. That's why we have this equal to sign. Understood? So whatever we are looking at is decreasing. Now you must have, you must have already thought about it. The next type of function is a strictly decreasing function. All right. So we are going to understand about what is a strictly decreasing function now. See, in a strictly decreasing function, so here what we have, x1 is less than x2, but f of x1 is greater than f of x2. Understood? So in the sense here we are going to have a graph which is maybe something like See, like maybe something like this one. Fine. Maybe e power minus x graph. You can think of something like this. So this is a strictly decreasing function. All right. So now let next look at a different type of function. It's neither increasing nor decreasing. Okay, like that parabola. That is one of the examples. Okay, we'll discuss what is what in that one. All right. See, the next type of function we have neither decreasing nor increasing. It's like both. Fine. The parabola is a beautiful example. So here you have, sorry, here you are going to have the y-axis and x-axis, and you have a graph like this. Some parabolic function basically. So here x1 can be less than x2. F of x1, sometimes it is less than f of x2, and sometimes f of x1 is greater than f of x2. So this is the reason why we tell that these are neither increasing nor decreasing function. So it neither goes up nor comes down, or it can happen both. Like if you take an example of sine curve, see, if you take an example of a sine curve goes like this, correct? It's increasing, decreasing. This is one possibility. Or the parabola where it decreases, then again increases. So there are multiple functions which are neither increasing nor decreasing. So these are different types of functions. Now the chapter or the topic name is application of derivatives. And here we are looking at functions. It's increasing, decreasing and all. Let's understand how we use the derivative to understand this one. All right. See, now let's do the derivative part. That means, say you have a function f of x. Okay, function f of x is continuous in a comma b and differentiable in a comma b. Like, you know, how we used to do for Rolle's theorem and all, the mid value theorem, mean value theorem and all. Very similar conditions. It should be both differentiable as well as continuous. And that too, it has to be differentiable and continuous in that interval a comma b, whatever the interval we are going to consider. All right. Now, f of x is that function which is differentiable and continuous in the range, or you can say from the limit a to b. Fine. Now, the first and foremost condition, that is, what if my f of x is this, and the first condition is what if f dash of x is greater than 0. Then f dash of x is greater than 0 in what? In that interval a comma b. Then we say that f of x is increasing, and increasing where? In that particular interval. So f of x is increasing in a comma b. Next, if f dash of x is less than 0, then f of x is decreasing in a comma b. What if is equal to 0? No, it can be, right? So if in case f dash of x is equal to 0, then f of x is neither increasing nor decreasing in a comma b. All right. Now let me show you an example. Let's keep it as it is. Say my function is f of x. Okay, say f of x is equal to, say, 3x cube. Let's take it easier. 3x cube plus 5x. Very simple. Do f dash of x. This is going to be 9x square plus 5. Correct? So 3 into 3 is 9, 9x square plus 5. Now, guys, if you look at it, x square can never be negative. So 9x square is always positive, right? So what do we have? This is always a positive number. And for a positive number, we are adding 5, which is again a positive number. So can we say that f dash of x is always greater than 0. So since f dash of x is greater than 0, according to this statement, according to that one, f of x, that is nothing but this particular question, f of x. This particular function is an increasing function, because when you differentiated, you calculated that f dash of x is greater than 0. So this particular function is an increasing function. So this is how derivatives are used in understanding whether the function is increasing or decreasing. Fair enough? Now in the next video onwards, we'll directly jump into the problems. Fine. Different types of problems are there. We'll look into all those things in the next video.